11 to 12.
11 to 12. I'll be trying to join these classes whenever I can, but most of the time I don't think it will be possible for me to join them. Okay, so we will be meeting, and I'll be checking on your on the page, see what things need to be done. So I think we'll be meeting in this particular time slot, 14 to 16. The other thing is down here there is this. Now, this is for your reference. Okay, if you need something, whatever you're trying to do, if it involves lists, it involves tuples, if it involves a set, you can look up something here. I'm also going to add, because I have been teaching some other group of students where I have been making video recordings. So I'm also going to add links to the videos on YouTube. So if you need a refresher on something, you can go and watch and see how something is done. And this especially applies to those who do not have any Python background. Yes, we are going to try to do whatever we can to help you, but in the case where you do not have any Python background and we still need to use Python background, I would encourage you to print out these materials, look at them and try to see what's happening. But also during the weekend, I'm going to post links which match these topics. So those links, when you click on them, they will send you to a YouTube video where I'm explaining the material in question, so that you know how to do things as well. I really do not have specific time to teach you people how to do things in Python. You have to do a bit of things on your own. And again, for some of you, it's not really the first time you are coming across this material, but there might be some material which is new. And you also have access to the books which we gave you earlier when you did the course. We can add the books. If people so wish, I can create another topic where we add the books so that you can read for yourself how something is done. I'm not against that. I'm all about people picking up a book and reading and knowing how to do something. The more books you read, the better you become at stuff like this. It depends on how much reading you're doing, how many videos you're watching. So the more you watch, the more you read, the better you become at this thing, because Python is a language. Are we clear? If you think you're going to know a language, but you don't speak it, you don't read books about this language, like you're trying to learn about English, but you never speak any English, you're just hoping that you know how to speak English. You're just hoping that you know how to write English, but you never read any newspapers, you never read any novels, you never watch any English movies, you never listen to any English music. It's going to be very difficult. The same applies with this thing, trying to talk to your computer using this language called Python. We have put a guide on the things which we need you to know so that you can make a success of all this process. Okay? But you need to read. There is no substitute for you picking up one of the books we're going to add, then you read them. You need to read. You might get stuck somewhere. If you get stuck, you can come and ask. Okay? So reading has to be done. There is no substitution for that. Are we clear? Reading needs to happen. There is no substitute for that. I downloaded some of your course notes. The first one was this one, lecture 2. There's some stuff. Yeah. What we have been asked to plot blackbody radiation. So basically we've been asked to produce caves like this. This is the kind of cave we have been asked to produce. That's what Professor Jane once done, that we produce a cave like this at a couple of temperatures, at 7,000 kelvins, at 5,800 kelvins, and at 300 kelvins. So the first thing is these caves have to be produced, and they have to be on the same graph, and later on we have to do some integration under the caves. So it might take us a couple of sessions, but that's one of the things which need to be done. Okay, are we clear on the task at hand? Then A, that's B, then C, find the maxima and minimum of the caves shown that agrees with Wayne's law. Okay, are we clear on what needs to be done?
Yes.
Yeah.
Yes.
Yeah, so the first thing is really making plots. Okay, so I'm going to be using there's a Jupyter notebooks, that's fine. But there's also another tool known as Google CallUp, which is what you're going to try to use. So you go on Google, you search for Google CallUp, you search for this. And by the way, we are also recording things. So a recording is going to be made available. You search for this Google CallUp. So when you search for Google CallUp, this is what you're going to get. You're going to get CallUp, then research, google.com, then Google CallUp. Under this Google CallUp thing, we want to just click on it. So when you click on it, it's going to bring up something like this. Okay? If you have used it before, then you're going to get something called recent, the things you have done recently with the CallUp. What items have you done recently with the CallUp? For example, I was teaching the third years, that's what I was using, and you see it shows the time or when last I opened up something. So in this case, what we need is we need to create a new notebook. So here, I click on new notebook. Then when I click on new notebook, this is what I get. I should get something which is fresh. This notebook is the same as the ones you have used for Jupyter notebooks. It's actually a Jupyter notebook, but it's being run by Google. Okay? The issue I'm trying to avoid is maybe your computer is old, or maybe you don't know how to install the Python thing properly. But if you have got access to a Google email, then you also have access to this thing. You have got access to a Google thing CallUp like this. So what we're going to do here, the title here of the notebooks, so it's entitled to IP Interactive Python Notebook. So the name of the lab is what? PHY Experiment 1, Blackbody Radiation, I think. Blackbody, yeah. What does it say? Blackbody Radiation Caves, yes. So we're going to say there. So PHY 48, I think 4815. Experiment 1. Yeah, we say Blackbody radiation caves. So that's the title of our notebook. So we're going to do everything here, play around with the thing until we produce the caves we need. So that's how you put your title. And as you can see, there is Google CallUp. So you're using two different things here. There's Google CallUp here. There's also this. So your notebook, when you save, is stored on your Google Drive. So let's hope your Google Drive is not full. Otherwise, if you don't have access to CallUp, you can still use Jupyter Notebook. With the CallUp business, you get access. When I say connect here, as you're going to see, I'll click on connect here. So I'll connect to some computers which are going to be given by Google. They'll give us access to a computer which has got nice RAM and also some 100 gigabytes space for us to do whatever things we need to do. Okay, it's saying connected, as you can see here. Then if I bring my mouse here, then you get some information. It says connected to Python 3 Google Compute Engine backend. The RAM we have been given right now, we are only using 0.79 GB out of 12.72 GB. So I've been given a maximum we can have access to, depending on what computation we need to do, up to 12.7 GB of RAM, and the disk space up to 107 GB. So basically it's as simple as that. So we have access. It doesn't matter how slow your computer is or how old it is. If you get onto Google Colab, then you have got access. You get access to high-end computing results. You can also do something else before you start. Yes?
Rachel is requesting to join.
Who is requesting to join? But I haven't seen any request.
Saying you are.
I've not seen any request.
Send a text on WhatsApp saying.
Why should someone send a text on WhatsApp? Is that where you send your thing? So that if I reply to the WhatsApp, then I'm not seeing any request here, as you can see.
Alright.
Yeah, because there is no unless she doesn't know how to access the meeting. As you can see, you are seeing my screen. There is no request. So I'm not seeing any request here. Let her try again. Okay. You can also decide, when you have a notebook like this, you can decide to work with other people. That's why it's called CallUp. You can collaborate with your friends so that you share the same notebook. This one that works. I don't know how you're going to divide the tasks. If you decide to do that, say this guy is going to do this part is going to, you can decide to share by clicking there on share. Here where it says shows two people here. So right now it's myself, then I can add people. For example, if I click here, there's some people who are in my thing. So I type your name. If we are friends, you have sent me an email before, then I type there. If your name comes in, I can click on you, then we add you, then you have access to the notebook. So you can actually work with other people so that you can solve your problems. Since it's a notebook, there are two types. Yeah. There it is. You see? So whatever someone was saying that they were asking, I don't really know exactly, because it shows. So the next thing you can do, since it's a notebook, remember when you're doing the Jupyter notebooks, there was the markdown cell where we typed our texts. There was also the code cell where we put our stuff. We can actually do the same thing with this notebook. Here, what we have here is a code cell. It has got something which looks like a play thing here, which is for running. You can also add a text cell there. So here is a text cell, then up there it's a code cell. If I want to type things, this is a text cell. It says double click to edit. You can double click to edit. I can do that. Then this edit thing comes up. When this edit thing comes up, then I can say I want to show certain things. I can say PHY 48 15 experiment 1. You can say Blackbody radiation caps. Blackbody radiation caps. So as I'm typing this thing, you start seeing what I'm typing this side on the left hand side looks like on the right hand side. So as you type, you see what you're typing or you're formatting, the thing you're doing looks like on your left hand side. If I am happy with what I've typed, then I come this side here. There are these things. This is for moving your cell up. Since I want this to be the title, I'm going to move it up like that, so it becomes the first item there. Then the other one comes like that. If that's not what I want, I can move it down like that. When I move it down, then that other code cell becomes the one which is going up. So if this is going to be our title, okay, so that's what you have there. Then if I want to edit it, there's a pencil here, down here. So there is moving up. You move it down, move cell down. Then there is link to a cell. You can add a comment as you are doing it, as you are collaborating with your friends. If you want to comment on something you don't understand, you can add a comment on a cell. Here you can edit, you can delete a cell. You click on those things, you can copy a cell, you can cut. So there's a couple of things you can do. So what we want to do is want to continue editing things. So if you do an edit like that, so there are a couple of things you can do. For example, in here, there is this bit here. This is for adding the title. This is for making your text bold. This is for making your text italic. This is for making your text look like code cell. This is for linking, inserting an internet link. If you want to insert an image, if you want to indent your text, if you want to add a numbered list, if you want to add bullet lists, what is this for? A horizontal roller, then yeah, reposition markdown, stuff like that. So in our case, of course, what we want to add, the first thing we want to add most likely is a title. So we'll click there. So when you click on title, it adds a hash sign at the end there, a pound. So the whole thing, this whole thing changes like that. If you are happy with this, then you come and click here. You close the markdown. So what you have here is what is called the markdown editor. So you close the markdown editor if you're happy there. So basically now whatever it is we typed now has changed into this. If you're still not happy with this, maybe you want to make things bold or you want to make it italic, depending on what you want. You click on the cell, you come back to the edit, then you select what you can select that like that. If you do this, that's going to make your thing bold, or it's going to make it italic. It's going to make it format code-like. So you most likely want to make it bold. When you make it bold, that's what happens. If you're happy, you close your editor, And this is what you end up with. So I'm trying to show the same stuff which we kind of did with the the Jupyter business. Okay. Next, if you're still not happy, you still want to make some changes, maybe you want to italic or something, like for example, I prefer to do a format thing like this so that our thing looks like that, and I like this better. So that could be the title for our experiment. What things do we need to do? What are we being told to do? We can look up some text. Okay, so the first thing we're supposed to do, as you can see, A, B, C. So the first thing you're supposed to do is use the Planck's body radiation equation law and draw black body radiation curves for black bodies at temperatures of 7,000 kelvins, 5,800 kelvins, and 3,000 kelvins. Try the plotting of the three caves on the same page on a common set of axes. If there are any difficulties with this due to caves being separated by large distances, you can draw the caves on separate pages. So that's the first thing you're supposed to do. So we need to do a bit of typing. So use the black body radiation equation. So the first thing you're supposed to do. So we go back here, we add another text thing. So we can say aims of the experiments. We can say aims of the experiment. We want to add another title, so we can do that. I can also add another one like that, so it looks like that. If I'm happy, I do bold. If I still want to do something, I do that. Then, so the first thing is I want to do, whether it's numbered or bullet, it doesn't really, if you want numbered, then you end up having a list like this. So you type your things here. So use the Planck's body radiation equation. So use Planck's black body radiation equation. Black body radiation equation. Law and draw black body radiation curves and draw black body radiation curves at temperatures of 7,000, at temperatures of 7,000 kelvins, 5,800 kelvins, and 300 kelvins. Try plotting the three caves on the same page on a common set of axes. Try plotting the three caves on the same page on the same page on a common set of axes. set of axes. If there are difficulties in this, so if there are difficulties in this, next is what? Due to caves being separated by large distance, this, due to caves being separated by large distance, large distance, distances, you can draw the caves on separate pages. You can draw the caves on separate pages. So that's the first bit. If I'm happy with what I've written typed in the first bits, I can now click on this thing and see what the whole thing looks like. Are we clear? Are we clear on how this thing is working? If I still want to do some edit, list number 2, item 2, find the emissive power, find the total emissive power, find total emissive power by integrating each of the 3 caves, each of the 3 caves i.e. finding the area under each of the caves, show that it conforms with the Stefan Boltzmann law. Show that it conforms with the Stefan law. 3. Find the maximum for each of the caves and show that it agrees with Wayne's law. Find the maximum for each of the caves, and show that it agrees with Wayne's law. Okay, so that's what we have been asked to do. There. So those are our objectives. We make the plots for the 3 different temperatures. We put the plots on something, then we start working out whatever integration things we need to do. We know how to do the trapezoidal or Simpson, that kind of stuff, integration which you can do. Any questions? So far?
Sir, how are you highlighting like the name for Stephen Postman's law and Wayne's law?
So I click on the edit here. If I want to highlight something like Planck's here, Planck, I select it. Then I click this one and that one. So when I do that, it adds this title thing here, that these things have been added. Then I select this again. Then I click on board here. When I click on board, then these things are added at the beginning and at the end. And you see the result is that the Planck has been made board and stuff like that. Is that clear? So you use the same way you use your you use your Microsoft Word. That's what this thing is for. This is an editor. Are we clear?
Yes, sir.
Yeah, that's an editor. Okay, just a few minutes. Give me a few, unless you've got any other questions. I need a couple of minutes. Then I'll come back.
Mukuka, Chai. You would think about it.
Okay, so the next thing we need is this Blackbody radiation law. That's what the next thing we need. What does it look like? So we add another text. So we say Blackbody. If I do that, then you just type Blackbody. Say Blackbody radiation law. So I've got my Blackbody radiation law. I want to add a title. So that like this. Then I want to add another one. Then I highlight, add that. Then I highlight again, that. So say the Blackbody. I don't know if it's going to my Blackbody. Or is, I'm not sure if this thing is going to work. So it's B. Where is it? This which you have here. So B lambda B lambda T there. So you can see things are coming, whatever stuff. So this is how you type if you are trying to enter an equation. You try to type an equation. So you start with begin, then you say equation, then end equation. So in between here, then the thing starts typing. So the B, then if I want to do the small lambda, so I put an underscore, then open parentheses, curly brackets, then inside I type lambda, then T. Then after that, what is it we have? So there's a fraction which comes there. So it's saying a fraction is going to be dfrac, then open curly brackets. On top, I have 2 pi hc squared. So I have 2, then pi, then hc squared. 2 pi hc squared. Okay, then at the bottom I have got these lambda to the power 5. So this thing I've typed in the first curly brackets, the stuff I've typed in the first curly brackets is the stuff which shows up on top here. So when I do a select here, that stuff which shows up, this is what I've selected here. I've typed in the first curly brackets here. So when you say backslash dfrac, then 2 curly brackets, the first curly brackets is for the numerator stuff. Then the second curly brackets is for the denominator stuff. This bit here, backslash pi, this is for the pi. That one. So there's a 2, it's this one. Then the pi, then there's a h, then there's a c. C is for the Planck's constant, then the C is H is a Planck's constant, the C is the speed of light. So somehow we need the value for pi, we need value for Planck's constant, then that. Then at the bottom, as you can see here, we have lambda to the power 5. So that is going to be lambda raised to the power 5, and that's what it looks like, that's what it comes out. Then we have a bunch of things. I'll say left open curly brackets, then I'll say right close curly bracket. So that's what I've done. So this bit, the left curly bracket is this one, then the right bracket, yes.
Sorry to interrupt you, sir.
Yes.
I'm behind you now. You manage to write down the Blackbody law.
What?
I'm behind you now. You've written this Blackbody law here. Like where you are, how you are getting this, that you begin brackets, then there's an equation.
It's something, it's another language called LaTeX. So I'm trying to show you how you're going to do stuff. It's a language. It's a computer language also called LaTeX. A language we use for typing mathematical things. You can do the same thing in Word, but really things don't come out the way they're supposed to come out. So probably your friends in future are going to take physics, because we're trying to also introduce a more computer component to your physics course. So this is how we type things. Is that clear?
No, sir. My question is, I'm also doing it on CallUp here. Now,
Sorry?
I don't know how I can write the same equation, the Blackbody law.
You're also doing it that side.
Yes, sir. I'm also following, but I'm doing it with my computer.
Oh, so what has gone wrong then?
Now, for open this, I wanted the text. Now to write the Blackbody law, this part, like the question I've done. Now, to write the Blackbody the same law that you have given here.
You just type what I don't know what's wrong. What's wrong with the things I'm typing? Have you typed this bit?
How to type them?
How to type them?
Type in that bit. Okay, yes, okay. Now I've got everything.
Huh?
Oh, now I know how you got that.
Oh, you first start with a begin equation and end equation. You start with this part. Begin equation, then end equation. Then in the middle, because when you start, you're going to be like this. So begin equation, then you start end equation, then you come back here, you add some space there. In that space, you put that stuff, then it comes like that. Is it clear? Have you managed?
Yes, I see.
Okay. Then inside our brackets here, we have to put something there. It's supposed to be E expo to raise the power HC, then there's a lambda, then there's K, then there's T minus 1. So that's going to be E raise the power inside there, as you can see inside here, it's a bit of a fraction, then later on minus 1. Sorry. Then after that, we get a minus 1. Like this. Like that. So there is a E minus 1, but before that, there is a fraction which comes after the E, which is what you're going to put here. So for the fraction, like before, if you want to type a fraction, you start with backslash GFRAC, then curly brackets for the numerator, then another curly brackets, for the denominator. So the one for the numerator, it's HC. So there's HC there. That's what you're going to put there. So HC. And you see our HC up there. Then this other curly brackets is what you're going to use for the denominator. And for the denominator, we have lambda, I believe. yeah, lambda, is this lambda kt? I think lambda kt, if I'm not mistaken.
Yes.
It's lambda kt, right?
Yes. Yes.
Yeah. So backslash lambda, you can get your lambda like that, then k, then t. So you get that. So that's e to the power lambda kt, then minus 1. If you're happy, you can close, edit. So it comes out like this. If you want to explain certain things, maybe lambda is the wavelength, c is Planck's constant, h is Planck constant, like that, you can also do that. So you say edit, then after that, you can say where, then you can begin another thing, you can say begin. Now here you're going to do something called enumerate. Enumerate. Then you're going to say end enumerate. Then here you're going to start with the first one, the first enumerate thing you want to do. You say item. Does it recognize anything? Hold on. Let me see. No, it doesn't. Okay. This bit, I don't think it gets. Or we can just do the following, very simple, where I think we have got these dotted things here. We add a bulleted list. Let me see. If it works, that's fine. Lambda. It is not working. Okay. So I put a dollar sign, and then I put $2 signs because I want to type something like lambda, okay, which is a mathematical thing. So in between the $2 signs, then that's why I put the lambda. Lambda is the wavelength in, I think, micrometers. Another dollar sign, u in micrometers. So like that. H is Planck's constant. Planck constant. Then I add another one. C is the speed of light. The speed of light. K is Boltzmann's constant. Boltzmann constant. Sorry. T is the temperature. Kelvins. What else? Then the Bx B lambda T is the spectral emissivity power. So this one. So we say P naught lambda then T is the spectral emissivity power of blackbody. Okay. All right. If we are happy, if someone doesn't know what pi looks like, we can also add it for them. PI is pi. The number pi. Okay, if we're happy with what they've typed. Okay, so there we are. So we have the title of our experiments, we have the aims of our experiments, then we have the blackbody radiation law on which this thing is supposed to be based on. Then this is the blackbody radiation law, and this is all the things which we need. We need pi, we need wavelength, we need Planck's constant, we need the speed of light, we need K, we need the temperature in kelvins. Of course, the temperatures have been given. There is temperature at 7,000, I think. The temperature at 7,000, temperature at 5,800, temperature at 3,000 kelvin. So that's not supposed to be a problem. But there is also this guy. So this guy can also be written, from what I've seen in the notes, can also be written in a much more simpler way as equals to A than this. This looks much simpler. Okay? Are we clear? So there is this. This is going to be a bit kind of difficult to write a function for, but I think this is easier. Are we clear? This other bit is easier. Are there any questions? So the other bit I think is easier. So we're going to say the blackbody given by this, that. So this other same thing can also be written as, we add another text cell so that we don't fix ourselves into. So the blackbody radiation curve, radiation law. Now, I must say that I'm going to post a link to this, this IPython notebook. And what I expect you to do, as you are seeing what's happening, is also to download this thing. Because at some point, as I'm showing what I'm doing, you guys will have to start doing your things also. Okay? Using this as your template. So as much you can, the other guy who is repeating, that's fine. You can try to repeat what I'm doing, but this thing is going to be made available to you in your Moodle. Then you're going to download this notebook. Then you can start working with it. You can start working on your copy of the lab. Are we clear?
Yeah.
Yeah, so it's not really necessary for you to repeat after me. You can watch and try to understand how things came about. Oh, so this is what was done. This is what was done. This is what was done. So it's more important that you understand what I'm doing and how I'm doing things, because you will have access to this notebook, a copy of this notebook. You will request, you will not share. We will request you to download your own copy. Then you open that copy in your CallUp, you put it in your Google Drive, then you're going to work from there. Okay? Because at the moment, I don't think we have the lab manual which specifically says how these things are supposed to be done with Python. We don't have a lab manual for Python. So basically, we are just getting started with this thing. Okay? So it kind of saves you a bit of money on paying for a lab manual. So the Blackbody radiation law can also be expressed in a more simplified manner as follows. So again, we're trying to write an equation. So you begin, it's not difficult, you just begin with begin equation. So you begin equation, then that. So once you do that, then also you need to end. So you begin an equation, at some point you need to end that equation, end equation. Then begin equation, end equation, and in the middle here, again we start with B. This is for the subscript, then lambda, then T, then next comes the fraction, so dfrac, then what's going to be the numerator, what's going to be the denominator. So in our case, our numerator is going to be, according to the formula we have, the numerator is going to be A, then after the numerator is A, then the denominator is going to be lambda to the power. That's how you do the power thing. You use that, lambda to the power 5. Then after lambda to the power 5, then there's going to be this. There's going to be this. We need our brackets. Sorry, what is lambda to the power 5. Then I start with the left bit. So left, open brackets, then right, close bracket, like that. Then in between here, I will type E to the power, like that. Then inside the power E, after that there's going to be -1, like that. So E to that. So I've left space for the power thing, which is this bit, the B divided by lambda T. So that's a fraction. So you start with dfrac, then that's for the numerator, then the denominator, so say B, then divided by lambda multiplied by T. So that's what we get. Then where I can now make another dotted thing, list of items. So here, $sign, $2 where A equals what do we have? So A is equals to 2 pi h c squared, 2 pi h c squared, which is equals to, the value of that is 3.7405, 3.7405 times next is 10 to the power minus 16. So I just want to see how things are being done. 10 to the power minus 16. Then after that, we want to type the units of this thing, watts dot meter squared. So for that bit, we do this math rm, then inside math rm we say watt, then c dot meter. You should see what's happening. So the watt is this, that's that. Then if you want to add a dot, it's that, which is what we're doing here, c dot here, then up there, squared. So that's, if I'm happy with that bit, I'll say okay, this. So in this case, the A is this. A is 2 pi ch squared, and that's the value of the A, the way it is in the notes. We are not doing something out of the blue. The experiment is based on stuff you've done in class. Okay. Next is, what is the value of B? So B is equals to this one, BC divided by K. So that's a fraction. So D frac BC. HC. Not BC. HC. HC divided by K, which happens to be equals to, what value have you been given? 1.4388. So 1.4388, then times 10 to the power minus 2, 10 to the power minus 2, then we want to add units, so say math rm, then meters, c dot Kelvin, c dot Kelvin. Okay. All right. So this is what we have. So we have our, I think we have everything we need. Our radiation law in its original form, this, then in a more simplified manner, which is this. So that is something which people can work out. And we also have some constants, A and B, with their values, which are these. So now from here, now that everything which we need, the theory part has been typed, we can start doing the Python bit. So far, are we clear?
Yeah. Yes, sir, we are clear.
Okay, so we can start doing the Python bit. So what do we need?
Yes, and Mukuka, can you mute his mic?
Okay. So what we need now is to write an expression for this. We need to write an expression for this. We need the value for A, we need the value for B, we need values for temperature, T, we need, so that we can, for each temperature, we work out what the, the spectral emissivity power is. So, for that to do that, we can start by create certain things. Create variable A, create the variable A, okay, this is A, and store the value and store the value this value. So create variable A for storing this value. So we want to create a variable A which is going to hold this value. Okay, so that's going to be A equals to 3.7405 e to the power minus 16. That's your A. We can check if this value has been stored properly. So you can say print the value stored in A. In variable so you can do a print, see if things are okay. Print A. There. So we are getting started. Is this clear? This part where we store the value in A, then we print it. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Next, we create the value, create variable B. Create variable B. For storing the value. So the value you want to store with B in B is this one. That's the value I want to store in B. So that's create a code cell. So B is 1.4388 e to the power minus 2. Run that. Then you can say print the value stored in variable B. Okay, so there it is. So with these two statements, this one, we are sure that this stores the value of A in this value in A. We are sure that this stores the value, this value in B. Okay? However, if we are really going to make any progress, we also need to know the value for E. We need to know what the value for E is. So we need to get that from somewhere. So we're going to import something. We're going to import a module called math. So import math module. Okay. Now, if those of us who, so we're going to do that, then we see why we're interested in this math module. So we're going to say import math. Okay, so the import math happens there. The next, why are we interested in the math? Because it contains certain things. We'll say start list the contents of the math module, the one we have just imported. Why are we interested? So we're going to say print dir. So dir math. If you run this, you get a list of things. You get a bunch of things which are in math. But as you can see, the list is vertical. So because the list is vertical, what we normally tend to do is we say print dir math. When we do this print dir math, then we get a list which is horizontal like this. Among the things in this math thing, you see there is archicos, then all sorts of mathematical functions. But one of the things which is there is this little fella here, E. There is also other things which are of interest. For example, if we were still interested in pi, we would have been able to get its value from there. Okay? So that's why we are interested in the math module. The math module stores an accurate value of E. Are we clear? We can either use E or we can import the exponent function. Okay. So, is that clear? Yeah. So we're going to say from math module import E, and these are the things we're interested in. Import E and export. Yeah. Yeah. So we want to get E, want to have access to E in this guy. So we're going to say from math import E and XP. Come in. Come in. Boss, man, don't go wear a mask. Get out.
Sir,
You're not wearing a mask.
my dress is made like for face mask.
What?
The way my
No. Get out. Stop wasting my time. So we have done an import for E and then export. So here what we want to do, we can try to print E if we want to see if this thing worked. This so-called import we did. We can say print the variable E so I add a quote print E. If I do a print E, that's what I get. You see? So we have succeeded in getting a value of E from the math module, which we can use. We also got this, the export function. This export function is basically that. In other words, you can write this as I.E as E raised to the power X. Like that. And I think that's what's more suited for our problem. Because in our problem there is this. So this expo is equivalent to this. So in our case, we're going to print out expo with a value of 1. So that's going to be the same as e to the power 1. So that we see if what we have actually works. So print out expo the value of 1, which is the same as e raised to the power 1, like that. So when do they print? So print, we want to see if it works. Expo 1. There. So these two things are identical. There is print E, the value of E we got. The E value we got is just a value. But the other expression, expo with a value of 1, is actually a function. This is a function in which we can actually put in this stuff. Look at what we're trying to do. This E raised to the power B divided by lambda T. We can try to do that. Are we clear? Hello?
Clear.
Yeah. The problem with this version of whatever it is we are trying to do here, the problem with this version of the expo function we have, and what the expo function you have is that it accepts only one value at a time. Are we clear? The problem with this expo function is that it accepts only one value at a time. That is problematic because what we are trying to do, if you look at the task you have, is to produce curves. Okay? We are trying to produce curves, and as we'll be producing those curves, there is this guy, the wavelength. We have to generate a list of values of wavelength, and these values, this expo function has to do these things at the same time. If we make a simple list, for example, a list of two values, okay, then we try to work out the expo for these two values. If I say print expo, then I give it a list 1 and 2, then I run these, we might have problems there. You see, it says must be real number, not list. So this expo doesn't accept a list of numbers because we will need a list of numbers for the wavelengths. Remember, the curve we're trying to produce, where is that curve? It's like this. So we need, for a bunch of wavelengths, starting from 0, going up to somewhere 5, for a bunch of wavelengths, we will need to work out what is this bx, so that we can plot bx against a wavelength. We can't do it one at a time. Okay? We will not be able to do it one at a time. It's going to be too much. So, yes, we have access to an expo, but it is not the correct function. Okay? We have got access to math, yes, but we have accessed the E, but it's not the correct function. We are not using the correct module. Okay, the right module for us to do what we want to do is something called NumPy, a module called numeric Python. Okay. So we'll do the following. We'll just make a note. The functions found in the math module, only work with real numbers. They do not accept a list as input. So this is a limitation with math. Are we clear? This is a serious limitation with the math module. So we are forced to look for a solution somewhere else, and that's where the other thing comes in, something called NumPy. So next, we're going to import NumPy as NP. Now NumPy using alias NP. So we're saying import numpy as np. Then after importing numpy as np, we can have a look at what numpy brings to the table. List of contents associated with numpy module. This is something we're going to use a lot, so people better become familiar. So we're going to say print dir np. When we do that, we get a bunch of things. Actually, let me just say dir np. Let's say dir np. So we get a list of things. We also have like the turn function, test, but our interest is trapezoid. Our interest is supposed to be where are these the only ones I'm saying? Oh, this is where I started from. So there is more up here. Okay, so the start point of what you have done, dir np, it gives us a list. This list, as you can see, square brackets, and that list ends somewhere down here, very, very far. So what I want to show is that when you do dir something here, that's where it ends. Now what you have here with numpy is a list of things you can do with numpy. One of those things you can do is what we are interested in. We are interested in a number of things. We are interested in the value of e, the function e. So let's go to where the e is, the exponent function. Here it is. We are interested in this exponent function there. So numpy has got an exponent function which can work with lists. Are we clear? Numpy has an exponent function which can work with lists, and that's what we are interested in when we are accessing numpy. There is also the value for e. It also has got a value for e. There is e. So we can actually do the following. We can say print np.e. When you print np.e, we should be able to get the value for e. There it is again. That's the value for e. So we can have access to the value for e from numpy, but we can also have access to this other function, the expo function. So we can say print np. You start with np, which is the alias for the numpy, then expo. Then after that, if you want, you can just put one value. I think it should be able to work. There it is. But with this one, it allows you to work with something called an array. So I'm going to create a simple array. So I'm going to say, just going to say numbers. Then I'll say np.array. Then in this array, I'll put a list 1, 2, 3, 4, just for demonstration purposes, like that. Then next, we'll say print np dot export. Now we're going to give it these numbers. Oh, before I do that, I want to print out numbers, see what it looks like. Print numbers. So this is an array. It's not a list. It's a special, because in Python you can't do calculations with lists. Okay? You have to modify the list. So here it is. This is the list, but I'm modifying this list using NumPy into something called an array. I print numbers. So what I get when I print numbers is this. This is an array. The difference between an array and a list, yes, they've got square brackets, but when you look at an array, the commas are not there. These commas, which separate the numbers. For an array, the commas are not there. If you just say numbers, I think more information might be available to you. It will say array, then the list which was used to create that array. Are we clear? So now if I say np.export, then I say numbers, then I print this, I'm able to get each value that is going to be e to the power 1, it's this one. Then the second one is e to the power 2, it's this one. This is e to the power 3, it's that one. That is e to the power 4, it's that one. So we are able to work out at the same time, simultaneously at the same time, we should be able to work out, we have found a way of working out the expression e raised to the power whatever x is. Here, this e, then whatever b is going to be divided by whatever this is. Are we clear? So that, yes, so that is the version of the exponential function we're going to use. The version of the exponential function we're going to use going forward is the one we find in NumPy. I have put on your Moodle, I have put some information on how NumPy works. If you go on your Moodle, because this thing have to I have to go somewhere else. This thing will have to continue, this discussion will have to continue next week. So down here, chapter number 15, Introduction to Numeric Computation with NumPy, creating multidimensional arrays with NumPy, manipulating NG arrays, creating, so this whole 15 talks about NumPy. Then 16 is how you create graphs based on NumPy. So these two directly affect what we are trying to do. So I would encourage all of you to look at these materials between now and when we meet next Friday, as we continue trying to solve the task which is at hand. In the meantime, I will also make available this notebook which we are using, okay, so that you can download it and you can try to play around and see exactly what it is we have accomplished and what it is we have done so far. Are we clear?
Yes, sir.
Yeah. Any questions?
No question.
Yeah, I would encourage all of you to use the CallUp. Because as you can see, I don't have to install anything. Everything which I need is available on these Google computers. Everything, literally everything you need about Python is available on these computers. So I would encourage you to use CallUp. So in the meantime, let me go where I'm going. Whatever we have accomplished so far, I'm going to save this. Save on Drive. I'm going to save on Drive. Then I'll share a link in our Moodle, which you can access. Are we clear? So that you can also start looking at the same stuff. I'm showing what can work. I'm showing what doesn't work so that you know, because when you make your own program to make those plots, you should be straightforward that knowing that, oh, this version doesn't work, this works. Okay, like that. So yeah, we have to end here for today. We'll continue this discussion next week. In the meantime, if there are any problems, look at the notes on the NumPy, which I've put on the model there, and also on how to make a plot, so that we don't have any problems when we start making a plot next week. Say, how are we making this plot? Look at the notes I have put under there, chapter 15 and chapter 16. Okay, so see you next week.